Introduction to compiler phases. What is a compiler? A compiler is a computer program that translates computer code written in one programming language, the source code, into another language, which is the target code. The source program is usually a high-level language, whereas the target program is either assembly language or machine language. Compiler operates in 6 phases, which are Lexical Analyzer, Syntax Analyzer, Semantic Analyzer, Intermediate Code Generation, Code Optimization, and Code Generation. Each phase transforms the source program from one representation to another until it reaches the target program. The symbol table manager and the error handler, these both interact with the 6 phases. First is the Lexical Analyzer. Lexical phase reads the characters in the source program and groups them into a stream of tokens in which each token represents a set of characters. It could be an identifier, a keyword, or a punctuation character. By taking the statement as an example, which is position is equal to initial plus rate into 60, the tokens produced by Lexical are position as id1 equal is same, initial as id2 plus is same, rate as id3 multiply is same, and 60 is converted into a keyword, which is num. Second is Syntax Analyzer. This creates a hierarchical structure on the token stream. This structure is then called a syntax tree. The syntax tree has an interior node with fields. The first field is for operator, and then there are further 2 fields for left and right children. For example, if we take the previous example, the syntax tree would be: first is the operator, the second field is the ID, and then the operator, and then the tree continues until the statement is finished. Third is Semantic Analyzer. This phase checks the source program for semantic errors and gathers type information for the subsequent code generation phase. For example, in the previous example, typecasting is done. Intermediate code generation. The syntax and semantic analyzers generate an explicit intermediate representation of the source program. This should be easy to produce and easy to translate into a target program. The example is as below. Fifth is code optimization. This phase attempts to improve the intermediate code so that faster running machine code will result. In the below example, we take the previous code and a better and improved code is the result. Last, in the final phase, is the code generation. In the final phase of compiler, memory locations are selected for each of the variables used by the program. Then, each intermediate instruction is translated into a sequence of machine instructions that perform the same task. For example, taking the previous code, we've turned this code into assembly language, which the machine will better understand.